This is Chapter 18 of Learning Web Design, which covers more advanced CSS techniques, including a primer on responsive web design. The chapter starts with a discussion of a so-called user agent style sheet. These style sheets are loaded by the browser before the page itself loads. They provide default settings that can be overridden later on in the cascading process. These default settings cover every conceivable property for every possible HTML element. To see the full list, just inspect an element in Chrome Developer Tools and click the Computed tab on the right. All of the settings are shown in pink and red. The pink ones are default for the user agent style sheet, and the red ones are overrides loaded later in the cascading process. So even though the designer might not set the background size or left border width, the browser always has default settings so that it can use them to render the element anyway. The problem with user agent style sheets is that browser vendors are not obliged to use the same default settings. While one browser may use 8 pixels as default padding for paragraphs, another might use half an em instead. While seemingly slight, half an em might be only a quarter pixel away from 8 pixels, for instance. These variations can be a constant source of frustration for designers, as their designs seem to mysteriously break in some browsers and work fine in others. The solution is to use a CSS reset. A CSS reset is a modular style sheet that the designer can load first, immediately after the user agent style sheet, to override the browser defaults to known settings. They don't actually reset everything, just the default settings that vary from browser to browser. Most sites today use one of 2 reset style sheets. The first, reset.css, was released in 2008 by Eric Meyer. It sets pretty much every layout-related property to 0 units. Thus, any non-zero setting is by definition provided by the designer. The second, normalized.css, is designed to work with HTML5 and CSS3. Instead of zeroing everything, it instead uses some common settings that work well in every browser. This potentially relieves designers from having to override settings that are already at sensible defaults. While the adoption of custom fonts in CSS3 has vastly improved the available selection of typefaces for the web, there are still times when the designer may want to display an image instead of text for a headline, for example. However, while the headline images may look nice to most users, they don't work at all for screen readers for the blind or for the web crawlers used by Google and others to index your pages. The solution is to supply the headline text as usual in the HTML, but then replace it with the image in the CSS. There are lots of ways to do this, but most are based on the so-called column technique. The technique works its magic through a combination of 3 property settings. First, the text indent of the element is set to 100%, pushing it off to the right, outside of the original element box. Second, the element's overflow is set to hidden so the text does not display on the page. Finally, the background is set to display the image without having it clutter up the HTML. Here's an example from the book of the column technique. First, the element box is sized to fit the image, which is then set as the background. Next, the text is pushed outside the element box using a 100% text indent and non-wrapping white space. Finally, the text is hidden using the overflow property. The result is the image is displayed to users on the screen, but the text is what appears in the HTML. That makes the text still visible to screen readers and web crawlers, which ignore the CSS in favor of what's in the HTML. A cousin of sorts of the image replacement problem is what to do with all those tiny graphic icons for things like social networks, badges, and themed decorations. While the files may be tiny, perhaps a kilobyte or 2, On a slow network, each round trip to the web server to request the image can delay the page load by as much as half a second. Even a few icons can then cause the user to abandon the page as being too slow to load. CSS Sprites solve the problem by combining all the image icons into one image file so that there is just one round trip to the web server. Each icon is then shown individually as needed through careful use of the background property. Here's the sprite technique in use for a cluster of social networking icons. Each icon acts as a button that links to a different service. The icons are sent to the browser as one file called social.ping. Then the background of each button is positioned so that just the relevant part of the social.ping image is shown to the user. The effect is the same as it would be if the image were displayed separately as a linked image. While CSS sprites are pretty powerful, there's another technique that deserves at least passing mention. If the designer is willing to use very simple, flat icons without multiple colors, gradients, or other graphic decoration, then an icon font can be used instead. Each icon is then represented as a character, say F for Facebook and G for Google. The icon font then displays the F character as a flat version of the Facebook logo, and the G character as a flat version of the Google logo. The icon font can then be cached by the browser, just like all other fonts, so that the next time the user visits the page there's no need to request it at all. In an aside, the book introduces the idea of CSS compilers that can greatly reduce the amount of CSS coding needed to implement things like CSS sprites. The two most popular of these frameworks are SASS and Less. Each replaces the usual CSS syntax with their own custom scripting language. The SASS and Less files are then compiled to produce CSS that can be linked into our pages. Thus, CSS becomes the output of a scripting process. While this may seem confusing at first, isn't knowing CSS enough? Why do we need yet another language? The frameworks can sometimes replace literally hundreds of lines of CSS code with a few lines of script. Some say that this approach is the future of CSS, and in fact some of the features of these frameworks, like variables and calculations, are making their way into proposals for future CSS standards. The book devotes a number of pages to advanced styling for forms and tables. The basic problem is that many people find the default styling of tables and forms to be ugly, and in some cases less than user-friendly. There are lots of ways to correct these problems with CSS 3. However, given that many of these same fixes will be reused over and over again anyway, it's usually better to use a CSS framework like Bootstrap or Pure to handle form and table styling. Besides being easier for the designer, using a popular framework also increases the chances that the styling will feel familiar and friendlier to the user. The chapter concludes with a primer on responsive web design, a topic that deserves its own chapter in the next edition of the book. Responsive web design takes the problem of providing page layouts that adjust automatically to fit the window size, orientation, and language settings, base font size, and other factors. The responsive approach extends the concepts behind fluid design to do more than can be done with percentage widths. There are three basic requirements, really four. The first is that the browser needs to let CSS know the size of the window before the CSS is applied. Second, a fluid layout grid is used to make columns and other elements scale with a browser window. Next, all images need to be as fluid as possible as well, resizing as needed to fit the space without becoming distorted. Lastly, media queries are used to allow the style rules themselves to adapt to the current situation. We'll cover all four of these requirements one at a time. Setting the viewport is a basic requirement for responsive layout. It requires us to insert the markup shown here in blue into the head of the HTML document. Without it, pages shrink to teeny tiny sizes on cell phones. The image on the left is a screenshot of the Fairfield University website as it would appear on a cell phone without setting the viewport. Links become unclickable because our fat fingers can't select them. Text shrinks to unreadable sizes. All around, it's a bad experience. The image on the right is what the site actually looks like on a phone. Links are clickable, text is readable, and images display about as large as possible. We can't get this nice layout without first setting the viewport. The second requirement, fluid layouts, was covered in Chapter 16. If you're using a modern CSS framework, then it almost certainly includes a responsive grid. The third requirement, fluid images, is almost as easy as setting the viewport. All one has to do is remove the height and width from an image in the HTML and then set the max width to 100% in the CSS. Note in passing that while this may cause images to stretch to fill the space, it does not prevent large images from being downloaded over cell networks. To do that, you need an adaptive solution, something that we're working on right now for inclusion in CSS 3. Here we return to the Newsweek magazine example from Chapter 16. It uses a mix of fluid and fixed images. The lead image at the top is fluid, resizing to fit the window. The smaller feature images below, like the one of basketball player Kevin Love, stay the same size throughout. Instead, the whole page changes layouts just at the width where the smaller images would fill the whole column. The trick to variable page layout is using media queries, which allow us to apply CSS rules conditionally, depending on the screen dimensions and other factors. The syntax looks a lot like normal CSS rules, only this kind of rule operates at a meta level on the rules themselves. Like any other CSS rule, there's a selector followed by curly brackets. The selector in this case specifies the device and viewport conditions under which the media query applies. Inside the brackets are any number of CSS rules to follow under the conditions specified by the selector. For example, the media query on the bottom of the page here displays that my block takes up 98% of available width whenever the viewport width is 800 pixels or less. If we wanted the query to apply on large screens, we could use min width instead of max width for the viewport conditions. Media queries are a key component of mobile-first design. At mobile-first design, one designs pages to work well on the smallest screens before considering layouts for larger screens. Once the mobile design is set, then media queries are used to progressively enhance the layout to suit larger screens. The screen sizes where the styling changes are called breakpoints. The book provides a graphic displaying common breakpoints. Each represents the full screen viewing width on a common device in either portrait or landscape mode. These widths make excellent starting points when choosing breakpoint widths for responsive layouts. At the least, the designer should design the site to work well at each of these breakpoints. Of course, since new devices are released seemingly every day, one should also test at intermediate widths between the breakpoints. That's what responsive design is all about after all, right? We conclude the chapter with a responsive design example from the Fairfield University Business Plan Competition website. For most competitors, their first experience with the website is at the kickoff event in September. Rather than rely on students remembering to sign up for the competition after getting back to the dorm rooms, they're asked to register right from their seats using their cell phones. Thus, the user experience is truly mobile first in this case. However, the design also has to work well on larger screens, since just about every interaction after that first sign-up is likely to happen on their laptops in their dorm rooms. To see the power of responsive web design approach, let's see what the page looks like as we shrink it from laptop widths down to mobile. At 960 pixels wide, the main content area features a large picture carousel that includes space on the right for a caption. In the masthead above the carousel, there is a navigation menu with drop-downs and a menu of user links along the top. Below the carousel is a menu of 6 action buttons for the 6 most common use cases for the site. At 760 pixels wide, the font sizes are slightly smaller so that nothing overflows its container block. The carousel pictures are slightly smaller as well. At 560 pixels wide, the navigation menu at the top changes from drop-downs to a mobile-style touch menu. The caption shifts from the right side to the bottom of the carousel so that the text doesn't crowd out the picture. The caption text shrinks to look more like a figure caption as well. At 360 pixels wide, the register and login links drop below the logo, and the navigation menu moves to the left side of the page. Meanwhile, the action buttons change their orientation from horizontal to vertical and display a little touch arrow to indicate that they're tappable on a touch screen. The media queries for all of this are stubbed out on the left. The base styling is mobile first, designed for narrow devices like cell phones or small tablets. Media queries with breakpoints at 510 pixels, 600 pixels, 800 pixels, and 900 pixels then cascade in with styling for successively larger devices. When combined with a fluid grid and responsive images, the layout appears to morph seamlessly from one layout to the next to provide the best user experience possible at every viewport width. This concludes the CSS section of the book. By this point in the course, you should be ready to handle the needs of the most basic websites without too much trouble. To get better and be able to handle more complex websites, you'll need to put what you know into practice. Thank you for following along with Chapter 18 of Learning Web Design. See you later.